Emostel.
Yeah, hi there. This is Emmanuel Kadri and you're welcome to Emostel Academy. In this video, I'm going to be introducing you to logarithms. All right, you are seeing a lot of things. You could see a lot of things at my back. Don't be scared, don't be intimidated. I'm going to make sure I explain everything and break it down to you that you would understand regardless of your foundation. All right, so let's ride. Good. So in this topic called logarithm, this is just the part one. We are going to cover a couple of series of videos on this same topic. Okay. All right. So good. There is a general form. There is a general form of logarithms that you should understand. Logarithm is like the reverse of indices. If you have not yet watched our videos on indices, you may just click the letter I button up there in the video, and then it will take you to that topic on indices. So you may want to go through everything on indices before you come to learn about logarithms. They are very much related. So this is like the opposite or the reverse of indices in some ways. Okay, now let's just check it out. Good. If, for instance, you have this log b um, r is equal to p. Log b r is equal to p. Okay, please take note that this stands for the base. This is the base of the logarithm. If just like we have this 7 here, is the base to this logarithm. 3 is the base to this logarithm. 5 is the base to this logarithm. 2 is the base to this logarithm. And in the case where you don't have any base written here, okay, it is just a general form to let you know that it is to base 10, which means that the standard base in logarithm is base 10. So which means if you do not see anything written here, okay, it simply means that it is to base 10. But if it is to another base, you must definitely see something written. It will be written explicitly, even though it is 1. Even though that base is 1, it will be written explicitly. But if it is not written, know in your mind that the logarithm is to base 10. Okay, good. So this is the base of the logarithm. Why this stands as the power of the indices. That the logarithm is formed from. You are going to understand that. Why this r is just, let me put it as the results. That is, if we intend to convert this logarithm to indices, this is the logarithm form. This you have here is the logarithmic form. But if you want to have it in index form, it's going to come this way. This b will carry this power p. It's going to be like b raised to power p. B raised to power p is equal to this r. So it just as if I'm saying that b raised to power p is equal to, gives us this result r. So this is it in indices form. This is it in the logarithms form. All right. So this is the stuff in index form. This is the stuff in logarithm form. Whatever you see here as the base carries this power, okay? Why this one is like the result of that indices. Let me just quickly show you some real life example. If you have something like this, maybe you have log If you have it this way, the log 2 to base 8 is equal to x. The question says find x. Or maybe they just said simplify log 2 to base 8. Simplify log 2 to base 8. It could just be written like this ordinarily. Okay? Could just write it ordinarily like this. And then it goes simplify log 2 to base 8. It's still the same way. Okay? If you ask to simplify it, you may just put the x yourself or something like that. Okay, to simplify it means to just break it down and you stop at the last point where you cannot do anything anymore. Okay, but in case it is equated to x, that it is equated to something, and then you have to just solve for that stuff, which is like x here. Then you follow this manner, you follow this pattern. What you do here is log 2 to base 8 is equal to x. Just use this rule, okay? The base is going to carry the power. So you have it as 2 raised power x, then it's equal to this 8 here. Okay, so if you apply the laws of logarithm, Or before you even do that, apart from the laws of logarithm, you can just simplify, not law of logarithm, I wanted to say indices. Before we apply the law of indices to this question, you may just still further break it down by saying 2 raised to power x is equal to this 8 here. You can raise it to 2 raised to power 3. 8 is like 2 raised to power 3 means 2 times 2 times 2. That's in 3 places, 1, 2, 3. Okay, that's the meaning of 3 raised to power 3. So 2 times 2 is 4, 4 times 2 is 8. So instead of writing 8, you could convert it to 2 raised to power 3. And then according to the law of indices, if the bases are equal, then it means the powers are also equal. So when you have this, so it's not as if 2 is cancelling 2 ideally. It's a law of equal base. So when the bases are equal, then the powers are also equal. So since you have 2, 2 here, you say x is equal to 3. That is the answer. Do you get that? So this 2 here now is the base of the logarithm, okay? So if the bases are equal, then the powers are equal, and then you have it that way, x is equal to 3. You see that? By applying this fundamental logarithmic form, converting the logarithmic form to index form, you then further simplify, you get the results. So that's it. And this is the reason why we could come to this law here. This law here, the law here says log x to base x, log x to base x is equal to 1. Why is it like that? If you say log x to base x is equal to 1, if you want to convert it to index form, you will have it that x raised to power 1, right? You say x raised to power 1 is equal to this x here, all right, in index form, okay? And then, okay, sorry, x raised to power 1, this x here is carrying this 1, right? So x raised to power 1, ideally, we have it like x raised to power 1 in the indices, in the law of indices, any number raised to power 1 is equal to that number. And so that's the reason why we have it this way, that logarithm of the same base is equals to 1. Why? Because if you want to get this, if you carry this thing like this, x to power 1, if you convert it to indices, you have x to the power of 1. What will it give you? To give you this result. Like I said, this r is the result, okay? Why this p is the power, and then this b is the base. So x raised to power 1 will give you this result, x, ideally, because any number raised to power 1 is equal to that number. You get that now, according to the law of indices. All right. Meanwhile, law of indices also tells us that x raised to power 0 is equal to 1. And if you watch that video on indices, I told you it's not even only x, even though it is a number, 1 billion raised to power 0, the answer is 1. 2 million raised to power 0, the answer is 1. 5 billion, 5 zillion raised to power 0, the answer is 1. Letter Q raised to power 0, the answer is 1. So be it a letter or a number, regardless of the size, the result is always 1 when it is raised to the power of 0. Meanwhile, on the other hand, anything raised to power 1 is equal to that thing. But anything raised to power 0 is equal to 1, okay? So x raised to power 1 is x. Anything raised to power 1 is that thing. Then on the other hand, anything raised to power 0 is 1. And so that's the reason why we have this sixth law here. This sixth law here, which says log x to the power of 1 is equal to 0. So meaning because x raised to power 0 is equal to 1. So this 1 happens to be the result of x raised to power 0. You get that? So that is where this law came from. Log x to base x equals to 1, and log 1 to base x is equal to what? 0. So this stuff here, they are very useful when you are solving logarithms generally. But I just discussed it. The origin or the roots of this law is from the laws of indices. So which means that it's as if we use logarithm to reverse indices. And so that is the way it goes. Hope you got that very clearly. Good. Now, if I'm too fast, you can just reduce the speed of the video, or you can replay, or you can pause and check out what I did, and then you proceed again after you have understood. And if you still need further explanation over certain things, you may reach out to us on our lines and or register with us at Emostel Academy to join our inner circle so you can have direct contact with us for us to help you with your academic needs. Okay, now we move. Um, after so knowing fully well all these basic law, all these fundamental laws, then we can now go into other laws of logarithms. Okay, now the law number 1 says that logarithm x, sorry, let me just quickly take this off. right, so the first law here, which is called the product law. Product in mathematics simply means multiplication. Okay, so which means that whenever we have two stuffs multiplying, or even it could be more than two, it could be x, y, z, it could be, but whenever we have multiplication in logarithm, okay, when the number we are trying to take the logarithm of are multiplying each other, okay, and they have a base, then it's still the same thing as the addition of the individual numbers to that common base, which means that if you have something like, for instance, log 100, or let me say log 1000, okay? Log 1000 can be further broken down into something like this: log 100 or log 10 times 100. Okay, just an example, log 1000 can be broken down into log 10 times 100. And then you apply the law of logarithm. Law of logarithm says that whenever we have products, okay, of two numbers to a common logarithm, then it's still the same thing as what? The logarithm of the individual number, the addition of the logarithm of the individual numbers. So it's going to be like log 10 plus log 100. Does this not ring a bell? In the law of indices says that a raised to power x multiplied by a raised to power y is equal to a raised to power x plus y in law of indices, right? So, which means that when the base are multiplying each other, okay, we have a common base with the powers adding. It's just the same thing that we are having here, like the reverse of the case, okay? When we have two logarithms, when we have two numbers multiplying each other, it is the same thing as having each of them to the common base, then adding one another. So in that case, I told you that when the base is not written here, when the base is not written here, it is the same thing as base 10, okay? So you can just to help yourself, you can make it look like log 10 to base 10 plus log 10 to base 100, okay? Logarithm of the same base is equal to 1, just like what we have here. Log x base x is equal to 1, right? So you can have it that, okay, log of the same base is equal to 1. Even this stuff, you can further make it to be 10, 10, 10, okay? 10, 10, 10, then plus another log 10. Although this is just a long method of solving this, if you know the other laws very well, there is a shorter way to get this solved, which we are going to go into soon. So we have log 10, 10, 10, then which means another this, log 10, 10, in three places, right? Logarithm of the same base is 1, plus another 1, 1, plus another 1, 1. At the end of the day, you have the answer is what? 3. So which means that log 10 to base 1000, the answer is 3. You got that? So that is just the simple thing as per that. Using the first law, it's just an example. We are going to solve more examples. So I just use this to explain the first law of logarithm, the product law. All right. So on a similar note, if we are dividing, the same thing applies. Simply means that in case we are to divide, then instead of we using plus here, it's going to be minus. It's going to be minus. It's going to be subtraction. All right. So let's see. Keep this example. Remember that when we found log 1000, the result was 3. All right? Log 1000, the result was 3. I'm going to refer to this same question when I want to explain another law, which is the power law. But we are coming down there. Okay? But for now, let's just quickly do the quotient law. Okay. The quotient law implies that when we have two numbers dividing, okay, and then you have to take the logarithm of that scenario, is going to be like the logarithm to the same base, but subtracting each other. So if you have something like this now, log 100 over log 100 divided by, let me say, log 1000 divided by 100. I know, of course, you could actually break this thing down, 0 cancel 0, and find log 10 and get your results, yes. but I'm just trying to use this to prove a point, to prove the validity of this law. That's what I'm just trying to do, okay? So which means instead of us to just cut out this thing and then get log 10, and then log 10 to base 10 is equal to 1, instead of us doing that, to cut this one out, to divide them out, I don't want to divide them out. I just want to go through the long way just to explain the validity of this law, okay? So if you do that, what you're going to have here will be like log 10 to base, log 10 1000, right? We are not adding now, we are subtracting because they are dividing. So you have log 100. You get that? So log 1000 minus log 100. So what's going to happen next here? So log 1000 is going to be like, the result of log 1000 earlier was 3. So let's just take it that way. The result of log 1000 earlier was 3 minus, we want to find the result of log 100. So log 100, we can break it down to log 10, okay, times 10. Remember, okay, I'm just trying to solve it the long way just to prove a point. But there are better ways to solve this thing by applying the other kinds of laws, which we are going to get there soon. But just to prove that you can subtract when the number is dividing, okay, that's what I'm just trying to do here. We know earlier that log 1000 is 3 from the previous example. So let's keep repeating that. Why this one? This minus is minus here. So let's just keep everything here, all the affairs here in a square bracket until we get it to the minimum. So log 10, 10. So that will be log 10, because they are multiplying here, to be log 10 plus another log 10. So when the two stuffs in the bracket are multiplying, okay, you take the individual logarithm of each of them and add. So that's what the rule says. So you have 3 minus log 10, logarithm of the same base, okay, is equal to 1. Logarithm of the same base is equal to 1. So since we are dealing with log, and I told you that if nothing is written here, you know that it is 10. But if it is another base, then something must be written there. If nothing is written there, it's 10. So which means invariably we are looking at it as log 10, 10, and that's 1, plus another log 10, 10, that's another 1. So here we are having 3 minus 2. 3 minus 2 is equal to what? 1, because 1 plus 1 is 2. So we have 3 minus 2. So which means the result of this is 1, right? And we already knew from the beginning that the result is going to be 1, because if I did not go through this long process just to prove this law, if I didn't go through the long process, I would have just said log 1000 over 100, okay? 2 zeros goes. So we have log 10. Now having log 10, what happens there? Log of the same base is equal to what? 1. So that's what we would have just gotten straight up. But we went through this long way just to prove this law, and we still got the same results. So which shows that this law is true, is valid. Okay? So we've been able to explain the product law, we've been able to explain the quotient law. Now let's go to the third one, which is the power law. All right. As for the power law, okay, the power law is just trying to make us to understand that if a logarithm, okay, you are taking, this is the logarithm and the base, okay, and then this is the number, but the number itself is carrying a power. So whenever you have that kind of scenario, take the power back. That is, the power is going to multiply the logarithm, okay, which simply means if, for example, I have something like this, the question says find the logarithm of 1000. I'm going back to we see that we know the result of log 1000 earlier. The result of log 1000 earlier was 3. Remember, don't forget, from the first example to the second example, the result of log 1000 is 3. Now let's see whether we are going to get 3 by applying this same law to this power law. So which simply means that log 1000 can be changed to become log 10 raised to power 3, because 10 times 10 raised to power 3 means 10 times 10 times 10. And so 10 times 10 is 100, 100 times 10 is 1000. So we have this 1000 as 10 raised to power 3, right? So good. So in that case, we having log 10 raised to power 3 and then applying this law. So you are saying that log 10 raised to power 3 is just as if we are saying log 10, 10 raised to power 3, because nothing is written here. It means it is to base 10. I keep repeating that. So you have this structure now, the base, the number, the power. the base, the number, and the power to that number. Okay, so not the power of the logarithm, okay, but the power to that number. Now we are going to apply the law. The law says that the power will go and multiply the logarithm. So the power, which is 3, goes to multiply the logarithm to become 3 log 10. That is log 10 to base 10. I might decide not to write anything here. It's still okay. But we know in our mind that there is a base 10 there. Okay? So we can have it as this, as 3 log 10. So having it as 3 log 10, okay? Well, let me just keep it there just for you, to help you understand better. So 3 log 10, at the end of the day, it means 3 multiplied by a logarithm of the same base is what? Logarithm of a number to the same base. When the number is the same thing as the base, it's always equal to 1. So 3 times 1 is what? Is 3. You see that we have been able to get the results of log 1000 as 3 in different methods, in different ways, and we keep getting the same results as 3, which shows that all these rules are very much valid, okay? All these rules are very much valid. So we have it this way. So we've been able to prove the power law, which says that when a number is carrying a power, the power goes to multiply the logarithm. The logarithm of a number is carrying a power. The number itself is carrying the power. The number goes to multiply the logarithm. So which means 3 goes to multiply log 10. All right, so it's no longer behaving as a power. It's now behaving like a product of that logarithm, like the multiplication with that logarithm. Okay, so that as per that. All right, so we are done with the power law of logarithm. Now we go to the change of base law. All right, so um, the change of base law is applied if you wish to change the base of a logarithm. Maybe you add an initial value and you want to just change the base, or you have a reason to change the base because by the time you start solving some advanced questions, you might have reasons why you want to change bases. Do you understand? So just to be able to arrive at expected results, you may want to change some base. It might be a strategy, you understand, or one thing or the other just to change base. So whenever you change the base of a logarithm, to change the base of a logarithm, you follow this rule. Very simple. The rule says that log x to a is equal to log px, then log pa, where p is the new base that we change to. All right. So if I have log 1000 and I desire to change it to, it was in base 10 before, right? So let's write it out explicitly as base 10. Okay, so now it was in base 10, but somehow I wish to change it to something in base 2, something like in base 2. All right, so if I have it this way, or let me just use another number, maybe, I don't know, 25 to base 10, okay? It's still all good. So let's say I wish to change this to base 2. If I wish to change it to base 2, let me put it, to change this from base 10 to base 2, the new base is going to feature. We are going to have it as what? Log, the new base now, which is 2 to 25, divided by log the new base now to 10. You get that? So the new base you introduce will feature in both the numerator and the denominator. While 25, okay, will repeat itself here as the same 25, but 10, that was a base before, okay, will now become a number in the new change. 10, which was a base before, becomes a number in the new adjustments. You see that? So then you now simplify further from these points. Okay, so you can find log 25 to base 2, you find log 10 to base 2, you get your result, and you are good to go. All right, but I'm not interested in doing that in this question because, okay, let me try to do that. Um, Instead of 10 here, let me just make this 100. So it's 100. So let's solve it out. So we have log 25 to base 100 is equal to, we want to change it to base 2. So let's find the value of log 25 to base 2. Logarithm of 25 to base 2, let's say it is equal to x. It means that we are going to have 2 raised power x is equal to 25, right? Then it means 2 raised power x is equal to 5 raised power 2, because 5 raised power 2 is 25, 5 times 5 is 25. So, um, sorry, I need a number that's, okay. So let me just change the example to something that can be simplified easily. So let's say this is 8. Sorry for all that. Let's take this to be 8. Okay, so everything here 8. I just want to use it to prove to prove a point. Okay, so we have other examples here to play with. The prepared examples are here to play with, but I just want to use this to explain this law, then to see how we can maneuver through it. So we have 2 raised power x, so is equal to 8 is like 2 raised power 3, okay? At the end of the day, so x equal base, so equal power. So it means that x is equal to 3. So so the answer for the numerator is 3. Then we go to we check out for the denominator too. So we have log 200, right? So we can apply this law, this power law, to solve this. I went through a long process to get this one, but we can apply the power law. So instead of saying log 2 to base 10, we could just say log 2, 10 raised power 2, right? So 100 is the same thing as 10 raised power 2. Just the same way we would have said 8 is 2 raised power 3, then 3 log 2, 2. Okay, so however you choose to solve it, you still keep getting the same answer in as much as you're applying the correct rules. So here, you just have like 10 raised power 2. Then according to the law of logarithm, we have 2 log 10. Okay, 2 log 2, 2. Okay, all right. 2 log 2, 2. Okay, I cannot use log 2, 2 here now because we are dealing with power of 10. Sorry. Okay, we are dealing with 10. Okay, so these two goes as a power. It has 2, then log 2, 10. So that's how it's going to be. But log 10 to base 2, we have to find that one and then multiply it by 2. So it's not going to work that way. All right. So, and even though you use the other way, you use this one, you are going to have it like, let's say log 10. If you want to solve it even the other way around, okay. So the way we did this one, you can have log 200 is equal to y. Okay, then we want to solve for y. So we now say 2 raised power y, okay, is equal to 100. All right. So still, 2 raised power y will be equal to 2 raised power y will be equal to 10 raised power 2. And then we are not having equal base here. So it wouldn't work, but it would have worked if we have a number that 2 can easily go in. Okay. So for that now we could use okay, we could use 16. Okay, please, this is not a prepared example. It's just something I want to use to explain this. All right, and that's the reason why I have to start changing figures and all that all the time. So this is 16. Um, this one will be 16. Okay, so if that be the case, to solve for the denominator, we have log 216 is equal to, if I don't want to use this method, okay, I want to use the power method, it still goes. So we have log 2 raised power 4, because 16 is 2 raised power 4. Then this power, we multiply the logarithm to give us 4, then log 2, 2. Then logarithm of the same base is equal to 1. So we have 4 times 1, which is equal to what? 4. And that is that. So which means the denominator now will give us 4. So the answer to this question is 3 over 4, which means log 8 to base 16 is equal to 3 over 4. All right, it's 3 over 4. And that is that as per that. So if you want to solve this question the other way around, like you don't want to apply the change of base rule, you just want to go straight to the point, you could do this way. Log 16 like log 2, this is 16, okay? Then it can give us log 2 raised to power 3. Then that would mean 3 log 2 to be 16, all right? So we can find the value of log 2 to be 16 by saying, I believe you've understood this one already, so I can take it out. So you can have something like this, 3, then just let's solve log 16 to base 2. So this one will be like log 16, log 2 to base 16. We can make it to be equal to x, okay? Just to solve this part out alone. Solve this part out alone. Let's just say log 2 to base 16. There are other methods too. There is also another rule for power of a base. Power of a base. There's another rule. I don't think I included it here. So I'm going to put it as an additional rule. There's a rule for power of a base, but just see as the rule works. In this case now, instead of writing log 16, we can say 2 raised to power 4. Then after the 2 raised to power 4, like this, then we have 2. Okay? So 2 raised to power 4, 2. The law for power of a base is that this power, this 4 itself is going to, we are going to put the reciprocal. The law says that, I'm sorry, please pardon me, I didn't include it in the basic law, but just understand this, just have this for your own perusal, okay? That's if log b is raised to power p, and then we have x, okay? Which means this is the number itself, logarithm of this number to base b that is carrying a power. In this case now, the base itself is carrying a power. The law says that 1 over p, that is the power, the reciprocal of that power, will multiply log b, then log x to base b. Okay? Remember that when the number is carrying a power, the power will multiply the logarithm. But in this case, when the base is carrying a power, then the reciprocal of that power will multiply the logarithm. Okay? So instead of us having directly the power of the base multiplying the logarithm, we have it as the reciprocal of that power multiplying the logarithm. So that law is what we are going to apply here. So knowing fully well that this log 2 raised to power 4, then 2, all right? So we are going to have it that this 3 is still excusing them while we carry out this operation for these parts in this bracket. This 3 is 3 out here. We are simplifying this part, log 16, log 2 to be 16. That's what we are doing here. So we change the power 16 to 2 raised to power 4. Then we now bring it out as 1 over 4, okay? 1 over 4 log 2 to base 2, which means we have dealt with this power. We have brought it out as a reciprocal, then log 2 to base 2. We know that logarithm for the same base, okay? When the base is equal to the number and you are taking the logarithm, the answer is 1. Okay, so we now have 3 multiplied by 1 over 4 multiplied by 1. So this one turns to 1. So 1 over 4 times 1 is 1. Multiplied by is 3. So we have 3 over 4. All right? So 3 times 1 times 1 is 3, then 4 over 4. So 4 times invisible 1. And so we got this, and that is the end. So we see that if we apply the change of base rule, we got 3 over 4. By applying the direct rule and then the inverse and the power of a base rule, we did everything and we still arrive at the same answer, 3 over 4. You keep getting the same results. You keep getting the same results, regardless of the method you apply. What is more important is that you apply the rights, you apply them properly, you follow the rules strictly, and then you solve the question carefully, and then you're always going to get the right answer. All right, so we've been able to touch every law that is written here, and then we added one more law, which is the power of a base law. So this thing would have been 7, perfect number. And so that is that. as per that. And so we have come to the end of this particular video on introduction to logarithm. So I believe that I've been able to introduce you to the basic laws of logarithm and how to apply those laws. So in the next video, we'll be solving some examples. So we start from the regular examples, then we go to some intermediate examples, okay? Then the advanced part of this is where we are going to be dealing with natural logarithms, but just follow the flow. See you in the next video. Bye.